friendly with Safari, so I had to do a ninja switch to Chrome. Okay, well, I'm really excited to be here right now. Thank you, Matt and Risa and all Kwaai leadership for giving me this opportunity to have a little talk about the not so popular cousin of AI, not as popular right now, LLMs, but as important as I will talk a little bit about it. So I'm going to talk about two topics that are strongly related, and that is image processing and computer vision. I'm Roman Pineda, as Matt say, and I am a PhD candidate for Anahuac University in Mexico, and also in collaboration with Universidad Autónoma de Madrid. So what are we talking when we say image processing? Well, images are everywhere. We produce images in our daily basis. Here you can see an example of a screen capture of an invoice of a video game I bought yesterday, but also an image of my briefcase. But we can capture the environment also with our mobile device. So we have a lot of images and that need to be used in some way. What do we do for image processing? Well, technically, a digital image is no more than a 3D matrix. And we need to remember that computers, well, for now, because we don't know what will happen next, can only understand binary representations or number representations. And what the computer do with the image is to convert it to numeric notation that I will represent a little bit later. Here we have an example of the famous Steamboat Willie. But what do we do with a digital image? Image processing is applying a mathematical function to a 3D matrix in order to obtain a new digital image. And where can this help? This can help with eliminating objects from an image, improving quality, and reducing noise. An example of that can be seen playing around a Python library that building a simple Python code, we can transform an image to a grayscale. Here we can see the Steamboat Willie, and part of the matrix that represent this image converted in NumPy, and applying a computer vision function, we can transform that into a grayscale with another numerical representation. The computer understands these numerical representations and can do things with it. This is a concept that has been for years in the computer vision and image processing world, but how can it relate and be useful to AI? Well, with one of my students called Andres Nuila, we made an image processing model to process medical images. We built a data set about 68,000 images to identify tumors, focusing specifically in lungs. So we collaborate with the College of Medicals in Honduras and build this data set, obtaining mixed results. As you can see, the accuracy is about 72% in F1 score. And we have 67% of classifying where an image is normal, and 88% when it is pneumonia, and 54% when it is tuberculosis. This is a practical example of how can improving this model could make a great assistance to the medical image processing and identifying diseases in early stage. as Christian says, over COVID-19, we made it with these specific lung diseases. This is how the evaluation process numbers gave around different epochs, and also the training loss of the process. Computer image processing also gave the step forward to a more robust computer vision process. This is a scene from one of the ruins in my country. I live in Honduras, and here you can identify the passage about the ruins, but also the currency of Honduras that is called lempira. We can sense it through our vision and identify the environment, and that allow us to interact with the environment. So computer vision allow intelligent agents to emulate human vision, and those agents can take decisions and also predictions that are mostly helpful in our AI world. Now with that, we can give a digital image as an input, and we will want to detect one or various environments and find a location on the image to make those decisions and also make predictions. The technical structure to support this is a very long concept that is called convoluted neural network, part of the deep learning process. And what it does is that from a 3D matrix, apply filters and try to separate to produce a layered output. These are called the convolutions. And with those convolutions and identifying objects, we can do a semantic segmentation. We've been talking about segmentation and semantics over large language models, but in the computer vision world, we can do the same. And identify these semantics could be useful in a lot of very ways. As in the previous case, on computer vision, in collaboration of one of my students called Javier, that's now an engineer, we create a system to identify students, and depending on the time they spend on a classroom, take assistance. So we built this architecture, mostly produced with Amazon Web Services, using this device that is AWS Deep Lens to identify a student. In this case, this is Javier, and count the time he's been on the classroom, tracking his movement. And if he stays above 40 minutes, it's taken as an assistant in a classroom. So this is very helpful because the model could identify the student and cross number account on the database of the university. And the process before this was very tedious because the assistant was taken on paper, and the paper could get damaged and get lost, and it's a more bureaucratic process that now is computer assisted. That is just one of the various use cases that computer vision can help. But to tie it down, how about Kwaai? How can we incorporate computer vision to our main vision? Well, here I have a small example that was an abstraction of our previous discussions over the operating system of Kwaai and how can we assist. And what we could think about in the future is to add a census framework, just like a human being. And this could be assisted by events generated by different devices that are both validated by a convolutional neural network to assist the computer vision, and also a large language model enriched by the functions that expose the operating system over a personal data space. making this can lead to very powerful use cases. In this case, answering things in natural language assisted by an image. This case asks the question of what is the color of the bird? And this textual representation combined with the visual representation of the image produced by the convoluted neural network to predict an answer. In this case, it's white. So I think it's a bright future that we are building and incorporating all these elements, not just the process of natural language, but supported as other senses. In this case, like image processing and computer vision could give us a more wide semantic context to assist the people and humanity. So I would like to thank for your time. This is my little dog Nala, and very sorry for the technical inconvenience, but I love to be here and I love to collaborate with Kwaai. So thank you so much.
That was awesome, Ramon. Thank you so much. Really fantastic presentation, and another awesome example of a lightning talk. Yeah, Afshin, go ahead.
Just a quick science question for you, Ramon, because you're doing some good work there.
Hey.
But so for the
Sure.
tumor part, what's